All right, so this lesson is called Characteristics of Parallelograms. Well, we've actually done characteristics of a parallelogram. It's just like, what do we know about a parallelogram? So right now, as we sit, I'm going to try to make this look like a parallelogram like we normally see. There we go. I mean, even if I kept it looking like a rectangle, that's still a parallelogram, isn't it? But this is kind of like your, quote, normal parallelogram looking figure. What do we know so far about a parallelogram? Okay. Are they equal, though? All four sides are parallel? There we go. Yeah, I got to get you to say it specifically. So there's two what? Two sets or two pairs, right? Because there's there's one set, there's another set, so there's two pairs, right? Because there's two in each. Two pairs of what? Parallel sides. Okay? And I think, is that the only thing we know so far? I think it is. I don't know if it was this class or the other class, maybe it was both classes. That somebody said something about the two sides, the two opposite sides. Okay, they are parallel. They're parallel by definition. Let's write that down. They're parallel by definition. All right, so if somebody says, well, why are the two sides parallel? Well, what would you say? Because it's defined that way, right? It's the definition of a parallelogram is a quadrilateral with two pairs of opposite parallel sides. Everybody got it? So that's by definition. Now, today what we're going to do is we're going to learn some more stuff about parallelograms. Now, we've learned different types of parallelograms. What are some of the different types of parallelograms we've talked about? A rhombus is a different type of parallelogram. A rectangle. A trapezoid. Is a trapezoid a parallelogram? No, it's not. What is it? A square. That's the other one, okay? So there's three specific types of parallelograms. And then there's like your ordinary, everyday, run-of-the-mill parallelogram. And that would be something like this. Everybody got it? But if all four sides are equal, that would be a rhombus. If all four angles were right angles, that would be a rectangle. If both of those things were true, all four sides equal and all four right angles, that would be a what? Square. But they're all what? Parallelograms, correct? What about a kite? That's something else we talked about. Is a kite a parallelogram? No, all right, because it doesn't have two pairs of opposite parallel sides. Actually, doesn't have any parallel sides on a kite. A trapezoid, how many opposite parallel sides does a trapezoid have? It's got, right, one pair. Very good. One pair of parallel sides. You got it? Okay. But what we're going to do today is going to be quite a bit of information that I'm going to give you today. So I would really write this down. I'm not going to write it as a theorem. I'm not going to write out all the words. I'm just going to show you on this picture right here. So we know they're parallel because of definition. Now, we have some theorems. All the rest of the things that we're going to do are all theorems. Theorems can be proven, all right? Just for the sake of time and the sake of ease, especially in a CP class and an honors class, I might go through and show why and show kind of a little proof. But for you guys, I am just going to tell you what is true. So, you know what? I said I wasn't going to write them down, but I think I will write some of these down because they're really not that long. So, what should I do? Let's do this. I was going to put everything on that one parallelogram, but I think that might make it way too messy. So I'm going to do one picture for each. All right, and I'll go a different color. All right, so here's, all these things are theorems. I already wrote that down. Let's do the first one. Here's the first theorem that we're going to talk about. It says consecutive, you've heard that word a bunch of times this year. Consecutive angles of a parallelogram are supplementary. And you've heard that word before. Somebody tell me what they remember about being supplementary. If it's supplementary, what happens when two angles are supplementary? They add up to 180. Very good. All right. So when angles are supplementary, they add up to, I'll put it in here, add to what? 180 degrees. All right. Consecutive angles. Which ones are the consecutive angles? Okay, the top left and the bottom left. I'm going to put 2 arcs here, 1 arc here, because they're not equal to each other, are they? Look at it. This one's obtuse, that one's acute. There's no way. These are supplementary. I was going to try to avoid doing this, but I can't help myself, okay? Remember, this was parallel to this, correct? Parallel lines cut by transversal, remember that stuff? Okay, we use that a lot throughout the book. All right, 2 parallel lines cut by transversal. These are called consecutive interior angles. And what did we learn back then, way back then, a couple chapters ago, about consecutive interior angles? They are what? Supplementary. So on a parallelogram, these are supplementary. You with me? Okay. And what are some other? I'll tell you what, let's do this. I'm going to stop right there on this, but then we're going to go back to it in a second after I show you this. So that's one thing. That's one of our theorems. I'll just put a little star there. Okay, that's one of our theorems. Here's another theorem. Is that the opposite angles, now they're not consecutive, they're opposite. Opposite angles are, I'll tell you what, let's just look at this and see if we, I'm glad I'm not the only one that bothered. All right, so look at the opposite angles. What do you think might be true? Just gut instinct. This one and this one. Yeah, they look exactly the same, don't they? Would you agree? All right, and they are. That's what that theorem says. The opposite angles are what? Equal. Okay? So this one and this one are equal to each other. So what about this? I guess I could have labeled these things. Yeah, let's do it. A, B, C, D. All right, so these two are opposite. D and B, or B and D, they're equal to each other. So angle A is also equal to what? Angle C. Very good. All right, so the opposite angles are equal. Again, remember I said I was going to go back to this? That also shows that all the consecutive angles are supplementary. So look, this angle and this angle are what? They're supplementary, okay? Because, I'll show you why. Look at these two. These are parallel lines. This is a transversal. So these are consecutive interior angles, okay, with line segments AD and BC. So they're supplementary. So A and B would add up to 180. What would B and C add up to be? 180, because they're consecutive. They're next to each other. You with me on that? They're next to each other. They're not across from each other. They're next to each other. So that means these two add up to 180. These two add up to 180. These add up to 180, and these two down here add up to 180. You got it? So that's that first theorem, okay, that they add up to 180. What's true about the angles that are opposite each other? They're equal to each other. Very good. All right? So that's 2 things that we didn't really know about parallelograms before today. We knew that you had those parallel sides, but you didn't know anything about those angles. We could have guessed. You might have looked at it and guessed that that was true, but now we can see it's true because of parallel lines cut by transversal. We good with that? Yeah, that's pretty easy, isn't it? Let's do another one. Everybody got that down? Okay. Let's do another one. I'm going to draw. Let's draw this. Let's make it white. There we go. All right, what's that look like? Looks like a rectangle. Do I know for a fact that it's a rectangle, though? No, I don't. Why not? I don't know if these are right angles or not. Now, they sure look like right angles, don't they? But does that mean they are? No. Until I do what? That's right. Put a little square in the corner. Okay? Now, I'll tell you what. Let's scooch this over. This has a little bit to do with what we just talked about, okay, being the consecutive angles being supplementary and the opposite angles being equal, all that good stuff. Okay, so let me write this down. I said at the beginning I wasn't going to write it, but I changed my mind. So here it goes. What do you think that's a symbol for right there? Parallelogram, right. So if a parallelogram has one right angle, then it is a rectangle. You're like, well, wait a minute, Mr. Hammer. I thought you said in order to be a rectangle, all four angles have to be rectangles or right angles, okay? But if I told you this was a parallelogram, all right, what did we just, somebody get the door, please? What did we just say is true about the other angles? So if this is 90, again, let's do this. W, X, Y, Z. So if this is 90, tell me what else is 90. Angle what? Well, because of being opposite angles, I should say that. So Y would be a right angle as well, wouldn't it? Because opposite angles are equal. Now, what do we know about W and Z? They must be what? Supplementary. So how do I find this? If I know this is 90, how do I find this? It's 180 what? That's it. Minus 90. You got it. Which, of course, is 90. So guess what angle Z is? It's 90. Now, you can look at X a couple different ways. Actually, 3 different ways. You could just say, well, it's opposite Z, right? So if it's opposite Z, what angle is it? It's 90. Or you could say it's supplementary to Y, which also makes it 90. Or it's supplementary to W, which also makes it 90. Everybody got that? Okay. So what do we got now? We got a parallelogram with 4 right angles. So what must this thing be? A what? A rectangle. Exactly right. And how much information did I give you at the beginning? I told you it was a parallelogram, and I told you just one of the angles was what? A right angle. Just with that information, you should be able to tell that the others are right angles, which means this now is a what? Rectangle. Make sense? All right, so that's kind of cool. Only knowing one angle, and just by knowing that little bit of information, I'm able to say that that's a rectangle. And we'll talk about rectangles more specifically later. All right, everybody good with that? Let's do another one. Another theorem. These are all theorems. And I'll tell you what, let's just do that. Push this over a little bit. Oops. There we go. Now, we talked about the opposite sides are parallel. How do we know the opposite sides are parallel when it's a parallelogram? Because of the what? It's the very first thing we talked about today, pretty much. How do I know? How do I know if this is if I told you this is a parallelogram, how do I know that these two are parallel? Because the definition, right? The definition says that these are parallel and these are parallel, right? But we have, let's go different color. We have a theorem. And this is something that you probably already figured out, all right? It's not that difficult. If you look at this side and this side, what do you think are true about the lengths of the sides? They're equal, exactly right. So on a parallelogram, the opposite sides are equal to each other. And again, you probably could have just guessed that. That was a gut instinct. Wouldn't you agree? Right? By looking at that? Sure. So what does the theorem say? It says the opposite, I'll just shorten opposite, the opposite sides are what? Are equal to each other. I'll just shorten it like that. Okay? So the opposite sides of a parallelogram, I should have put that in there, of a parallelogram. Okay? Not every quadrilateral, but if it's specifically a parallelogram, then the opposite sides are equal to each other. That's pretty easy, isn't it? Yeah. So obviously, what are they going to do on the quiz or test? They're going to say, that's 5 and that's 3. Find X and find Y. So what is X equal to? 5. What is Y equal to? 3. Now, you know they're not always going to make it that easy, though. What do you think they're going to eventually do? Yeah, they're going to go like X plus 5, X minus 1, or something like that, okay? And then what are you going to do? Yeah, but what do you do before you start solving? Set them equal to each other. Exactly right. You get me? All right. I don't know if that comes out or whatever. I just made those numbers up. But you would set them equal to each other. they would do the same thing with the y. Just set those equal to each other, and then you just solve, right? We kind of did a bunch of that stuff, like what, 2 days ago? Something like that. It was on the homework we went over, maybe yesterday. I forget. But yeah, you know what they're going to do. All right, let's do another one. We got like one more to do, and then we got a couple examples. Yep. All right, so let's do one more thing. We're going to learn one more thing, and then we're going to do some examples, and we're going to put it all together. All right, let's move this away. What if I drew a line from one corner to the other, non-consecutive side? See, that's a consecutive side, that's a consecutive. What if I drew that? What do we call that thing? What do we call that pink line right there? I didn't say I bisected it. What is it? No. We did this when we did that polygon thing, right? To find the sum of the angles. We talked about it dozens of times, maybe I said this word. When you did that polygon, remember we took from one point, we drew it to another one, to another one, to another one. We figured out how many triangles we had. What do we call this? Look it up. Some of you guys are flipping in your notes. That's a good thing. Do it. Flip in your notes. What do we call this? From here to here. It's an important word because we use it a lot. What? I'm not going to tell you what it starts with. That'd be too easy. What is that line called when I go from one corner to another corner? What is it? I didn't hear you. Heard you say something. What? No. No, I never said that this angle is equal to this angle. It's not a hypotenuse. It's only a hypotenuse if it's right triangle. All right, I'll give you a hint. Starts with a D. It's not diameter. It's not distance. Those all start with D's, but that's not what it is. Come on, guys. Did I not say this a bunch? It's a die. Oh my gosh. I'm going to spell the whole word before you figure it out. Might as well put it down. It's a diagonal, right? Absolutely, we said that. You go back, you watch that video when we did the sum of the angles of the polygon, and you count how many times I say diagonal, all right? I say it a bunch. I don't know if I say it, what did I say earlier, like 20, 30 times? I don't know if I said it that many times, but I said it a bunch, okay? So this is what? What is that pink one? It's a diagonal. Very good, okay? So what if I drew from this corner to this corner? What's that thing? A diagonal. Very good. All right, so we're going to be doing this quite a bit with these shapes. We're going to be doing this with a parallelogram. We're going to be doing it with a kite, a rhombus, a rectangle, okay? A whole bunch of stuff, squares. We're going to be talking about the diagonals, and there's a lot to know about these diagonals. And the first thing we're going to talk about is diagonal. Again, this is another theorem. It tells you something about the diagonals. And there's more than just what we're doing today about diagonals. Okay, the diagonals of what's this shape right here? Parallelogram, good. Okay, there's it's not a trapezoid. The diagonals of a parallelogram bisect each other. Now that's a word that we've used a lot before, isn't it? What does it mean when it bisects? It doesn't just go through it. It's got a prefix bi. What does that prefix bi mean? It means two. So what do these things do? They bisect each other, which means they don't just go through each other. They don't just intersect each other. And it's true, they do intersect each other, but how do they intersect each other? Alani, tell me. Oh, bathroom. I thought you had a great answer for my question. Bathroom. So what does it mean to bisect each other? Splits it into two equal parts, right? Not just into two. Anything could split into two, right? But two equal parts. So these two things right here. So let's go A, B, C, D. We'll put E. The diagonals of a parallelogram bisect each other. So here's two diagonals. AC is a diagonal, agreed? All right, BD is a diagonal. They intersect each other, but they do more than just intersect each other. By the way, where do they intersect each other? At E. at point E, right here. Not just in the middle. I put a point here. So where is that? That's point E. That's where they intersect each other, okay? But again, they do more than just intersect. What do? They bisect each other, which means they split each other into two equal parts. So that means that AE is going to equal what? What is it? EC. That's right, because this diagonal is being split in half. Everybody got it? Okay, so that diagonal AC is being split in half. That means AE equals CE. Well, this diagonal right here, BD, that's also being split in half. Now, AC and BD are not the same lengths, so I can't put one tick mark here because they're not all four the same. Would you agree? So I put two tick marks, one here, one here. So DE, let's write this down. So AE must equal what? Yeah, EC or CE. I'll put the E on the end. Is that all right? So that must be true. So the length of AE equals the length of CE. What else could we say? DE equals what? BE, right. So that's the stuff that we know because of this theorem. Okay, that theorem says that the diagonals bisect each other, so this is what we can figure out. Now again, you know what they're going to do, right? They're going to say that this is 3. So what does EC equal to? EC? EC's got to be 3. What is AC? 6. You got it. Okay, what if that was 5? What would BE be equal to? BE, B, boy, BE would be 5. What would BD be equal to? They all sound the same, don't they? BD, it would be 10. You got it? And again, like on the other one, you know what they're going to do, right? Make this x plus 2, make this 3x minus 1, set them equal to each other, solve for x, plug it back in. It's stuff that we've been doing all year long. Agreed? All right. Let's do an example. Yes. I guess. Let's do this. Actually, let's make it look a little different. Oh, I didn't change that. There we go. All right, let's make it look like this, and I'm just gonna lean it the other way. That's the way it looks in my notes, so that's the way I'm gonna draw it. Okay? And you really want to pay attention to what we're doing here, okay? Because there's a lot involved, but it shouldn't be that hard for you if you remember the stuff we just talked about. All right? This is A. You guys writing this down? Yeah. If you're writing this down, you shouldn't be laughing and giggling and all that kind of stuff. All right. Oh, goodness. What do they tell you? They tell you a bunch of stuff here. They tell you that AB is 6.3. All right, so I'm going to write 6.3 right there. And they tell you that AE is 4.2. So AE, where's that? Right here, 4.2. This is 6.3. This is 4.2. All right, they tell you BD. BD is the whole thing. I'm just going to write it right here. Is that right? Instead of trying to draw it on here because it could get a little sloppy. BD is 11.6. So BD, that's from one corner all the way to the other corner. All right? Now, they tell you a bunch of angles as well. They tell you angle ABC. Where's ABC? ABC, that's this whole angle right there. They tell you is 72 degrees. 72 degrees. Everybody with me? All right, and ACD, that's this little skinny one right here. They tell you that one. That's 63 degrees. 63 degrees. And one more thing they tell you, ABD. ABD. Tell you what, I'll make this a different color. ABD is this little one right here. It's not the whole 72. It's this one right here, and it's 41 degrees. So I'm going to put a 41 right there. I know it's a little small, but that's a 41. All right. My goodness, they told you lots of stuff, didn't they? But There's still a lot more things that you could find. So here's what they ask you to do. They ask you to find DC. Oops, not E. DC. They want you to find EC. These are line segments, right? And they want you to find ED. They also want you to find some angles. Okay. Angle DAB. So angle DAB, they want you to find. They want you to find angle ADC. And they want you to find angle DAC. This is one problem. Now look, I'm not going to put one problem on the test where you're going to find 6 different things, all right? I probably will make these each a different problem, okay, if I gave you something like this. Everybody understand? So I'd make that number 1, 2, 3, 4, 5, 6, all right? But this is one problem that they ask you to do here. All right, let's go through it. Let's do the sides first, DC. So DC, it's this one right here. That should be really, really easy to find. Let's do a different color. So DC, without any math at all, you should be able to find DC. What is it? 6.3, right? Because opposite sides are equal, correct? 6.3. What about EC? EC is this little one right here. That's another one that's really easy without doing any math at all. What is it? 4.2. You got it. So that's 4.2. So EC is 4.2. What about ED? ED. This one right here. Good question. Oh, that's right. I forgot. The BD thing. Right. Good. Thanks for reminding me. All right. Let's, because I didn't mark it on the picture. But BD, that whole thing is 11.6, right? ED is what? Half of it. So what's my math? 11.6 divided by 2. Okay, it's half, all right? So if you do the math, it's 5.8, okay? So that's 5.8. Everybody see that? All right, I forgot about that I put that up here. But that would be 5.8. There you go. So that was easy, wasn't it? One little math thing, you just had to divide by 2. That's all it was. Let's do the angles. DAB. There's D. There's A. There's B. So what am I looking for? Let's do some different colors. Let's go green. I'm looking for this whole big angle right there. It's not equal to 72 because 72 is up here. I'm looking for the one down here. They're not opposite, but they are consecutive. So what's the math that I do? Minus what? 72, right? Because remember, 72. They're consecutive interior angles minus 72. And that gives you what? 108? Yeah. All right. Everybody see that? They're consecutive, right? They're right next to each other. So that must mean they are supplementary. Supplementary means they add up to 180. So that would be 108 degrees. All right, we're getting there. Angle ADC. Where's that? ADC. That's this whole big angle right here. You could. Well, what did you say? 108 what? 63? There's no 63. That's a 6.3, and that's a side. 72. But what's an easier way to do it? So you could go 180 minus 108. You could have done that. Okay, but there's a lot easier way to do it. It's 72 because why? Because they're across from each other. But don't say across from each other, okay? All year long, I don't like you saying that. What do I say? They're what? They're not across from each other. They're... Look in your notes. I wrote it down. I said about the angles. What kind of angles? Look in your notes. Look in your notes. Still haven't heard it. Look at what kind of angles are equal to each other. Look in your notes. Look in your notes. You're not looking. It's in your notes. I'm going to show you. Look. What? Opposite. The opposite. That's sides. Okay, that's sides. But where did I do the opposite angles? Right there. There it is. See, look. If you looked in your notes, you would have seen that, right? So, we don't say across. We say what? Opposite. Okay. Go ahead, Sincere. What is it? It's 72 because the opposite angles are what to each other? They're equal to each other. So that's 72. That's ADC. One more. DAC. DAC. That's this little, let's do a different color again. I'm running out of colors. What color? I think I used, no, I haven't used pink yet. I used the pink one. All right, so it's this little angle right there. That little tiny angle is what I want to try to find. How do I find that? Well, I know the whole big angle, don't I? What's the whole big angle? It's 108. Okay. And then look, if this is 63, what's this angle right here? This one is 63. So how do I find this one? 108 minus 63. You got it. And what's that? 45? Okay. And there you go. 45 degrees. That was the trickiest one right there. All right. There's one more example, but it's kind of what we have talked about before. We almost finished, but I am going to still sign the homework. So here it is. So it's section 6.2. It's page 260. I am. You got an extra day to do it. So there you go. Have I ever said I don't give you homework during weekends? No. I give you homework weekends a lot. There it is. Okay, 1 to 17, 21 to 24. There may be a couple at the end you can't do because we didn't quite finish the lesson. But if you, anybody listening to me? If you watch the next class, I don't think I'm going to talk as much as I did at the beginning of this class. All right, so I'm going to get started right away. My guess is I'll probably have that whole lesson finished. So if you just want to watch the end of the other video, you should be able to see it. I hope you're still paying attention. Probably not.